Imagine this. Deep beneath your feet, hidden over 3,000 miles below, a mysterious engine is at work, one that could challenge everything you thought you knew about our planet. For decades, scientists believed that Earth's inner core, an iron-nickel sphere roughly the size of our moon, rotated smoothly and independently from the surface. But new seismic data tells an astonishing story. Since the early 2000s, the inner core has been gradually slowing down. Around 2009, its motion nearly stalled, and now evidence hints that it might even be nudging in the opposite direction. So, what does this mean? To understand, picture the inner core as part of Earth's hidden machinery. When an earthquake shakes our planet, the seismic waves race through its inner layers. By measuring these vibrations, geophysicists like Yi Yang and Xiaodong Song have started to decode the inner core's behavior. Their studies, published in journals like Nature Geoscience, reveal that the inner core's shift is not random. It's a change that could have deep implications. But why should you care? The inner core, while hidden and remote, is crucial because it powers Earth's magnetic field. This magnetic field is our planet's protective shield, deflecting harmful solar radiation, guiding compasses, and even influencing our modern technology, from satellite navigation and power grids to communications networks. When the inner core's rotation alters, the way it interacts with the surrounding liquid outer core changes. This interaction, known as the geodynamo process, creates and subtly sustains our magnetic field. Now imagine if that delicate balance is disturbed. A slowdown or a reversal in the inner core's rotation could distort the magnetic field. Even minor distortions might lead to fluctuations in field strength and stability. Such changes could alter the way charged particles from the Sun interact with Earth, potentially leading to increased space weather events. In practical terms, this means potential disruptions for satellites, navigation systems, and even our power grids, all of which rely on a stable magnetic environment. Right, let's dive into the science a bit more. The inner core is thought to rotate at a slightly different pace than the mantle, and that's all thanks to its isolation in a sea of liquid iron. Now, the outer core, which is in constant convective motion, generates electrical currents that produce our magnetic field. If the inner core's rotation slows down or even begins reversing, it could actually modify the flow patterns in the outer core. This change might, in turn, trigger a chain reaction where magnetic poles drift unpredictably or even weaken temporarily. As subtle as it may be, the ramifications could ripple upward into our everyday technology and, honestly, in our understanding of Earth's evolution. Scientists are watching these changes with growing interest. They're asking some key questions. Will the inner core ever speed up again? Could a reversal impact the periodic reversals of Earth's magnetic poles? Or is this shift just one phase in a larger cycle of acceleration and deceleration that our planet has undergone for eons? Answers are, well, slowly emerging through continuous seismic monitoring and computer-aided simulations that map these deep Earth dynamics with increasing precision. And while these shifts occur over timescales way beyond our daily lives, decades or even centuries, the insights they offer are actually quite profound. They remind us that Earth is not just a static rock, but a dynamic, evolving system. Even the slow, almost imperceptible changes in our planet's heartbeat can eventually lead to dramatic rearrangements in how we understand the forces that govern our environment. Before you take heart, or, hold your breath, remember, these processes are gradual. They're more a gentle reminder of Earth's perpetual motion than an alarm for immediate catastrophe. Yet, even subtle shifts in our magnetic field require our attention, as they really underscore the complexity and interconnected nature of our planet's inner workings. So what do you think? How might these deep-seated changes eventually ripple into surface life and our technological world? Share your thoughts in the comments as we explore the intricate dance of Earth's hidden forces together. Stay curious and remember, the deeper we look into Earth's mysteries, the stranger and more beautiful its story becomes. If you enjoyed this deep dive into the dynamic heart of our planet, be sure to like, share, and subscribe to the universe for more captivating journeys into science.